Okay, let's finish up our notes from when we were in school. You should have your notes open to the data distribution page. Data distribution is how the data values are clustered or how they're grouped together. Remember, we called it positively skewed or right-tailed if all of the values were on the lower side. We called it negatively skewed or left-tailed if most of our values were on the high side. And a normal distribution was when they were evenly distributed with the mean having the most in the middle. And it was symmetric around the mean. It was a symmetrical bell-shaped curve for the normal distribution. And the area underneath the curve was a probability with the total area being equal to 1 or 100%. We went over just about all of that before school left. So if you have more questions, let me know. You can pause the video to write in all of this stuff if you didn't write it while we were in class. But I'm going to move down to the empirical rule. So the empirical rule is where this actually becomes really helpful. The empirical rule tells us approximately 68.2% of the data falls in within one standard deviation. So we're talking right here. This blue highlighted section is 68.2% of my data. 95.4% is within 2 standard deviations of the mean. So if you go 2 standard deviations below, all the way up to 2 standard deviations above, you've got 95.4% of your data. And approximately 99.8% is 3 standard deviations away. So these 3 standard deviations on either side make up 99.8% of my data. So here's where that comes in really helpful. Say I wanted to find the percentage for each piece in this table. Well, I know that I can get this to drop down for me, or I can't. That 68.2% of my data makes those 2 pieces. And it's symmetric, so I know it's going to be equal. So I can take 68.2 divided by 2. It's going to give me 34.1. So I know each of these 2 middle pieces is 34.1% of my data. Now, if I wanted to find the 2 pieces outside of that, I know that the whole section is 95.4, but I can subtract out the middle. So I can go 95.4 minus my 68.2 and divide it by 2, because there's 2 pieces still. And that'll give me 13.6. I can do the same thing again to find the next 2 outermost pieces. I know that that is 99.8% of my data. I can subtract out the 4 middle pieces that I know, which is 95.4. And there's 2 of them, so I divide by 2. Each of these pieces end up being 2.2. And the little guys at the end. I know the whole thing is supposed to be 100%. I subtract out the 99.8% that I already have labeled and divide by 2. That leaves me with just an itty bitty little 0.1% for those little tiny pieces on the end. These percentages under the curve never change. They're always going to be the same. 1 standard deviation below to the mean is always going to be 34.1%. Anything higher than 3 standard deviations away is always going to make up 0.1%. So let's do some questions with it. Start by filling in your on the curve. We know they're always going to be the same. 0.1, 2.2, 13.6, 34.1, 34.1, 13.6, 2.2, and 0.1. Now the question says the weights of 50 football players are normally distributed with a mean of 178 pounds. Well, I know my curve is symmetric around my mean, which means my mean has to be in the middle. So I'm going to label this middle dotted line 178 pounds. And it has a standard deviation of 8 pounds. I know the next line forward is one more standard deviation. So I'm going to add 8. And I get 186. Find my next line, I add 8 more. And I get 194. Then I add 8 more. And I have 202. Now, if I wanted to go to the left, I know those are all one more standard deviation less. So I'm going to subtract 8 from both sides, or subtract 8, which leaves me with 170. For the next one, I subtract 8 more, which leaves me 162. And then I subtract 8 more, and I have 154. Now that I have all of those lines, I can go over to my questions and answer them. What percentage of the players weigh between 178 pounds and 194 pounds? Well, I know between those two weights are these two pieces. So I add them together. 34.1 plus 13.6. $34.1 plus 13.6, 47.7. So 47.7% of the players weigh between 178 pounds and 194 pounds. Do the same thing for the next one. It says at most 170 pounds. So that means I need them to weigh below 170 pounds. Well, there's 3 sections for that one. And I add them all together. 0.1 plus 2.2 plus 13.6 is a lovely 14.9%. So 14.9%, almost 15%, way below 170 pounds. What is the probability that a player weighs less than 162 pounds, but greater than 194 pounds? So I go and I say below 162 pounds is these two pieces. Above 198 pounds is these two pieces. Add them together. 0.1 plus 2.2 plus another 2.2 plus a 0.1 equals 4.8%. What if it asks how many players instead of for a probability? Well, I still do the first step between 170 pounds and 186 pounds. So that would be these two. So I have 68.2% if I add those two pieces together. But I don't want the probability, I want how many players. So I'm going to change my 68.2% to a decimal, 0.682, and multiply by my number of players, 50. And when you do 0.68 times 50, you get 34.1. Now you can't have 0.1 of a player, so round it. 34 players. So you need to know your percentages for the curve, figure out your numbers for the line, starting in the middle with the mean, adding or subtracting standard deviations, and then add together all of your sections for whatever the question's asking. Let's do one more example. Let's do number 4. I already wrote in my percentages. If you need to pause to write in yours, pause. Mrs. Fuller recently tested her 120 keyboard students to see how many words per minute they can type. The results were normally distributed with a mean of 45 and a standard deviation of 6. So mean of 45, I'm going to put 45 on my middle line and a standard deviation of 6. So to go to the right, I'm going to add 6 to each one. Whoops. And to go to the left, I'm going to subtract 6 from each one. And then I can answer my questions. Remember to double check if it says how many or if it says probability. How many students can type at least 39 words per minute? At least means that I need more than 39 or 39. So I'm going to count all of these ones above. 34.1 plus 34.1 plus 13.6 plus 2.2 plus 0.1. If it gives you an 84.1. Now remember it asked for how many. So I'm not going to stop at my percent. I'm going to change it to a decimal. 0.841 and multiply by the number of students. 0.841 times 120. Is 192 students, or 100.92 students. Now remember we round, and we're always going to round down and say about. So about 100 students. About how many students can type within one standard deviation of the mean? Now remember our empirical rule. One standard deviation of the mean is 68.2%. But again, I want how many. So I change it to a decimal and take 0.682 times it by my 120. Which is 81.84 students. So I round and say about 81 students. Last but not least, this one takes some critical thinking. A student needs to be in the top 2% in order to be eligible for the national typing competition. So 2% is going to be inside this line. Right about here is going to be 2%. If Carla can type 56 words per minute, is she eligible? Where's 56 in my number line? Comes before 57, right? So Carla's right about here. Is she inside that top 2% to make it to the national typing competition? No, she's outside. She's below 2%. the top 2%. So no, Carla is not eligible. And that's it. The percentages never change. Mean goes in the middle line. Add standard deviations on to go to the right. Subtract them to go to the left. And then read your question. See which portions of the graph you need. Add those percentages together. If it says how many, multiply by the number that were surveyed. That is all the rest of this unit has for you. Try and complete the worksheet. If you have any questions, feel free to email me, and we will have a Zoom meeting or potentially Google Meets on Wednesday.